So in terms of aviation, I think the commitment to the environment has always been there embedded in our development aims. I would say that probably historically, in the early years, these commitments were very much driven by the need to reduce fuel burn in aviation and in flights, just because we needed to make the sector economically viable and we needed to make the sector accessible to many other travelers and goods more widely. But in the later years, and much more since the 1990s, commitments have been very much by design. We first got together in the 1990s to set a number of challenging voluntary targets. The ones that everybody has committed right now from an aviation perspective are what we call the ACARE Flight Path 2050 in Europe, and there are others more widely through ATI and others. Aviation goals are directed at carbon emissions, but they're wider than that. We currently have commitments on emissions, on waste, noise, and materials, amongst others. For emissions in the short term, we've committed to net zero carbon growth from 2020. That's in 6 weeks' time, people. In the longer term, we've committed that in 2050, we will have reduced 75% of CO2 emissions, 90% of NOx emissions, and that aircraft will be emission-free when taxiing, all compared to a baseline new aircraft of the year 2000. So you've seen different numbers thrown at you during these couple of days. Depends on where you use the baseline. In terms of waste, we have committed that by 2050, every aircraft will be designed to be recyclable. In terms of noise, we've committed to 65% perceived noise reduction for all aircraft by 2050, again in comparison to a new aircraft of the year 2000. And there are many other commitments around hazardous materials and their use. There are commitments around the usage and the extraction of sustainable materials, and a continuous commitment of reducing the amount and the types of materials that we use. All of those, if it wasn't difficult enough, are directed as well to addressing the growth, which is between 3 and 4% RPK per year for the sector, and obviously increasing levels of efficiency so that we can continue to be competitive and continue to exist as a business. So now for the fun part. Fact, 2% of all global human-made carbon emissions come from aviation. Estimates show that if we looked at greenhouse gas emissions, including nitrous oxides, including particulates, and including vapor waste and others, this number could be even up to 5%. Some people have said this morning this is not a lot. To us, it is 5% too much. The CCC, which is the Committee for Climate Change in the UK, who advises government, the Department for Transport, on their aviation strategy, has estimated that by 2050, just 30 years from now, we could be the largest single contributor to CO2 emissions in the UK. Now, 30 years seems like a long time from now. And looking at the average age in the audience, you may not be around. You may be very well, sipping margaritas in a coastal location. But some of us will be here. And it is my dream that I will be here talking about the successes of this sector and how we have achieved this net zero. I do not want to be in the hot spot justifying why we didn't get there. So without further ado, I'll introduce the panel for today. We have Roger Gardner. Roger is probably known to many of you. He's been around the aviation industry for over 36 years. He's an advisor on aerospace and aviation in general to government. He has a link to the University of Southampton. He's the director of ATA, and he has his private consultancy business. So welcome, Roger. We have Martin Schofield. I had the pleasure to work with Martin from 2014 to 2017 when he was our head of technology for whole aircraft at the ATI. Martin has worked for over 38 years in UK blue chip companies, mainly British Aerospace and Rolls-Royce. He's an expert in aircraft conceptual design and operations. And he'll be talking to us about a paper that he developed for the DFT and the Committee on Climate Change on how we can decarbonize using technology. And finally, we have Chris Lewis. Chris is an expert in fuels in general, more so lately on sustainable aviation fuels. He retired from Rolls-Royce in 2014 after, again, 30-plus years of a career. He was responsible for their fuels whole process, really, from R&T to certification and in service. He's a visiting professor to Sheffield University, and he's also a director for his own consultancy. So I hope you welcome the panel, and I hope that we can give you a good introduction to this very interesting conversation around the environment. I'll just remind you that we are using Slido as well for this session. The code again is 4167, and this session is Vox for Environment. Thank you.
Thank you and good afternoon. Yes, I'm Roger Gardner. I think when Christina referred a moment ago to people not being around in 30 minutes ago, I thought you maybe was thinking a slightly more terminal sort of thing. If that was the case, I'm probably one of them. But ordinarily, when speakers have a lot of their thunder stolen by people who've gone before, they're really peeved. I'm actually really delighted because it really signifies that the topic of environment has really taken root within the sector and the broader community. So the consequence is you might hear a lot that you've already heard, but I think actually if that means that we're really making progress, then all to the good. So is that the right button? Is it just taking a little while to come on? Okay, second one. Okay. Right. So you've already heard from Christina about it's around about 5% if you include non-CO2 impacts. And I think that that's reasonably well accepted. But I just wanted to sort of say a little bit more about this scenario which Christina referred to. So this is CCC's work. It's maybe one of their slightly more aggressive scenarios, but it says that the blue segment on the left-hand side, which is aviation, is, as Christina said, the biggest single UK contributor in 2050. It's very clear that other sectors are decarbonising so much more quickly. We absolutely have to try and accelerate the pace of what aviation does in this respect. So I have no shame in emphasising that again. It's an existential threat, it really is. But this story is so much more complex than just CO2. So I've set out here on the left a little bit about all of the different impacts and indeed, in a very general sense, the sources of those impacts for aviation. And it goes right the way from the cradle of resources and materials right the way through to decommissioning. It covers the full operation of aircraft manufacturing, and I've slotted drones in there as well. And on the left-hand side, if you can see at the bottom, those bars represent all of the different impacts in terms of climate impacts, CO2, contrails, NOx, etc. Then the local impacts, and they're not just emissions ones. Clearly, there's a significant concern about particulate matter, about local NO2, but also noise, and then waste and resource use. It's a complex story. There are many different facets to this, and there are things that can go wrong. You can pull the wrong lever, you can have perverse effects. There's a lot to be checked through in order to make sure you get the right story. And the science isn't entirely clear. On non-CO2, there are still a number of uncertainties. Latest suggestions are, broadly, it's a doubling of CO2, maybe 1.1 to 3 as a range. So you really do need to get some clarity on that topic. If you look at the local impacts, there is a progressive loss of tolerance on local impacts. As aircraft get quieter, people perversely get more sensitized, and thresholds of acceptance go down, maybe accelerated by the fact that governments build ever closer to airports, but nonetheless, it is a major problem. So that is a problem associated with technology getting better, perversely. It shouldn't be, but it is. And also, there's this issue of local air quality impacts. The health story is there's no safe threshold for particulate matter. NO2 has effects on not only breathing, but also on longer distance O2. So that's another concern. Science is not clear on what those are, but there's a precautionary principle here that people probably have to follow. If you look at life cycle, that's another issue that's tucked away in here. There's been probably far too little activity within the sector as a whole that is talking about life cycle. And that is a topic that really does need to be built up further. On UAMs, I think one can say that that's a topic where you could specify that things should be carbon neutral, but you're still left with a noise problem. It's a new sector going in new locations at an uncomfortably low altitude with a particularly discrete and potentially annoying noise characteristic. That has the potential to cause real problems, and it needs to be worked through in detail. I think we can safely say that the technology story, as well set out over the last few days, is going in two directions. Gas turbines are going to be part of the future. It's liquid fuel. We really have to play into the space that Chris is going to talk about in the fuels department, but equally electrification. So there are two clear routes, I think, starting to emerge in this story that we really need to concentrate on. But we should not ignore hydrogen and fuel cells. That is still viewed by many companies, many organizations, as having real potential, and that therefore I think that that is worthy of keeping firmly in the sights in the research domain. But equally, we've seen massives of change in design and manufacturing. That is ostensibly good for the environment. It's doing a lot to reduce impacts. But we have uncertainties about new business models. We're going to start flying one stop to Australia, burn fuel to carry fuel, not good. Issues there to be worked through, and also issues about how does the models in relation to MRO and servitization actually change things. If we look at what the solution space is, I think it's effectively in two parts. The right-hand side, those two quadrants, are really the areas where the ATI can have purchase with the companies and organizations that are actually part of delivering new technologies and ways of using materials and manufacturing. On the left-hand side, you're really talking more about the airlines, the airports, the ATM communities, the broader system of people who are a part of actually enabling the whole of aviation, given that it's a systemic challenge. And that environment really goes right across the piece. So I think there's a message here which is it's about partnerships. And I think the new strategy is very much picking up on that one has to engage far more broadly, not only within the sector, but also outside in order to achieve learning from other communities. Just a couple of caveats, I think, that are worth entering here. The sector has to be profitable in order to be able to reinvest. This is a frequently stated story, but it's an absolutely crucial one. And without that, the sector will not be able to move forward into new technologies. On the competition side, it's a global story, global solutions. CO2 is a globally mixed gas. The experiences that people have around airports are globally felt. So it is a story which you can't do at the UK level alone. European, broader international collaboration is an essential part of delivering the solutions. And trade-offs, I briefly mentioned those. It's not just between impacts, it's also potentially between technologies. And there's a strong issue there about how policymakers want to actually play into the space. And clearly, there's competition for a limited source of fuels, which means that we probably have to go increasingly into e-fuels. So my final conclusions are, at this stage, and I've been doing some work with the ATI towards an insight paper and helping to unpack some of the future strategies on environmental issues. And I think that you can be clear that technology is still the key driver here. It absolutely has to be strongly influenced by the environmental agenda, and I believe that that has become ever stronger now. So that's fabulous. I think we also need to do far more in terms of collaborations. We need to make sure that we retain the fabulous innovation track record of aviation. The percentage improvements are stellar. The question is the curves flattening out? How do you transition on to the next thing? What's the point at which you cut and move to a new generation of technologies that will liberate improvement? And finally, I think that the new strategy is absolutely in the right space, and I'm delighted to see that environment is right up there as a priority. Thank you.
It is working, marvellous. Thank you, and good afternoon, everybody. I am Martin Schofield. I'm going to talk a little bit about the quantification of some of the things that we've been hearing about over the past day and a half. Last year, a small consortium which comprised of myself, Roger, and Professor Andreas Schaefer from UCL were invited by the Department for Transport and CCC to try and figure out what the technologies that are available to us in the aircraft, ATM, and operational space would do in terms of achieving reductions in CO2. So it's a fairly charged piece of work. We approached this by doing a huge, great big public literature search, looking at key technologies and what research establishments, what universities were saying about the potential to deliver on CO2 improvement, either explicitly through a fuel burn or CO2 basis or through constituent parts of aircraft characteristics such as weight, drag, and aerodynamic improvement. At the same time, we spent quite a bit of time making sure that, to the best of our ability, those particular analyses were then all on a common basis, because you can imagine if you've got a number of different organizations quoting, they'll be doing it on different bases. So we attempted to make sure that we could commonize that as best we could. They then asked us and said, well, okay, now you've done that work, what are the scenarios and how might those technologies play out to deliver into product over time? So we did that work last year. It's a 150-page report, which you'll be grateful to hear. I'm not going to go through in great detail because I've got 5 minutes to summarize it. But the reference is there, and I hope you'll get access to the reference, because if you're interested in the topic, I'd like you to read it, because there's some interesting assertions in there, there's some interesting assumptions in there, which I think the industry should have a go at challenging, to make sure that we've got broadly the right picture. Because DFT have got that document, DFT are using that document as part of their aerospace strategy development over the coming years. We worked within the DFT framework, and what they were asking us to do was to look at the benefit of technologies on an individual aircraft basis, not on a fleet-wide basis, an individual aircraft basis, in 4 class sizes. And the 4 class sizes are up there, and you'll see they effectively cover both the narrow body and the wide body sectors as we recognize them today. So we saw yesterday that that's pretty much 95% of the CO2 that the aviation industry is generating thus far. So that's good. That's good. But it does presuppose that the market environment that we have today will retain all the way back to 2050, and that may not be the case. So as I said before, we looked at on-aircraft technologies, we looked at operational technologies, in other words, how the aircraft is flown, and we looked at air traffic management technologies, which is, of course, how the air traffic system then interacts with those airplanes. So we had 3 areas to cover. Having done the work, we ended up with a whole raft of technologies at aircraft level, which is this particular list here. Many of them will be very familiar to you. So the things that we did was we had a look at the range of technologies and what they're going to bring in terms of CO2 improvement against each class. We looked at what the research said the likely TRL6 was going to be, Technology Readiness Level 6. And we then added 5 years to that to say that would be the earliest that the technology could be embodied in a new production airplane. And I'll talk about the consequence of that in a little while. We then had to make a subjective judgment. Which of those technologies were likely to make it through? So this is where the subjectivity comes into this analysis. And you'll see, and the way we've constructed the chart here, that a number of things had full inclusion, which meant that they were on all of the classes in all of the time spaces they were available for. Partial inclusion maybe meant that they were on some classes and not other for a variety of reasons, but also they may or may not have come in later rather than earlier. And then things that had no inclusion at all. In other words, we'd done the analysis, but we decided that because the analysis said these things weren't going to make it through. And there's a variety of reasons. Some of them because the level of technology improvement was actually quite small, but others had more complex reasons why. It may have been down to sort of the ability for the industry to actually develop these things in terms of a full business case. So we had to take some subjective views on those things. A couple of things I'd throw into there, for example, you will notice at the bottom, flying wing and open rotor were not included in the analysis because neither of them effectively passed our subjective judgment that these things were going to see the light of day on production vehicles in volume. So that's quite controversial and something maybe we can touch on in the panel section later on. Blimey, really? Good. Okay. Same thing then for operations and ATM. We went through the same activity with operations and ATM, and you can see again the list of things that we covered there. Many of them will be very familiar to them. Some of them are available now already, which is great, but some of them need a lot of work to be developed. The key thing that we introduced to the concept to DFT and CCC was what we called bundling. Effectively, what we reminded them was that just because a technology is available in a certain time frame, it doesn't mean it will automatically be introduced on an airplane. The airplane has to have a market opportunity to make it work. And we decided that given that we've already had 2 recent refreshes in both the narrow body and the wide body markets through NEO, MAX, 787, A350, and the new 777 families, then we were unlikely to have another one for quite some time to come. And so we said, there may be another market opportunity between 2030 and 2035, and there may be a second opportunity between 2045 and 2050. So we limited the introduction of those technologies in time frame terms to the availability of those time frames for those vehicles. We also then did some scenario planning looking at what was likely to get onto the airplane, what was an optimistic solution which we might make work after all, and what was very pessimistic. So what was the answer? Relative to the year 2000, in the analysis, we were looking at and a CARI goal improvement across all three areas, aircraft, ops, and ATM, of 75%. The nominal level of reduction we achieved was 32%, not 75%. The most optimistic was 52%, not 35. Not 75, excuse me. So the conclusion we drew from that, which is what you've heard other people talk about today, albeit maybe not numerically, was that technology alone is not going to be sufficient to achieve this target from that analysis. So what can be done? We've heard about pace. One of the things maybe we need to do is pace, improve the pace of what we're doing. Another thing that we might want to do is that there are a number of practical solutions that I've already referred to, which we said actually look very difficult. But given that we're not going to achieve the target, does that mean then we just redouble our efforts to make those difficult things achievable? So do we put more investment into flying wings? Do we put more investment into open rotor? Because they will help us get much closer to that target. Finally, this is something we left to DFT to do. They were going to then use the analysis to look at how the fleet mix changes. And if we move from very, very large airplanes to slightly smaller ones to achieve the same mission, that also has an improvement in CO2. How much exactly is very difficult because it depends very much on the fleet mix. But nonetheless, that might give us another degree of percentage improvement. It may not get us there still, but at least it's something that makes this picture perhaps look a bit better than the picture I've painted here today. The other thing, finally, clearly we were doing this on the basis of what was publicly available at the time. There may be a lot more stuff out there we didn't know anything about from a public perspective or couldn't talk about. The analysis was relatively simplistic in terms of the way it approached, in terms of looking at the integration of technologies. Perhaps more detailed analysis will help us get a better picture. But just remember, the number might get better, but equally the number might get worse. Thank you.
Okay. Almost as if it's planned, I'm going to talk about aviation fuels, sustainable aviation fuels, and I think I've won the technology bingo because I started counting the times people said SAF yesterday, and I lost count at about 10. I've got 5 minutes. I normally talk for at least an hour or two, but don't worry, I've got it down to 5 minutes and 5 slides because I've made a career of this. And I also tell people when I did that talk, and this is absolutely true, because in 2002 was when the dialogue really started about sustainable aviation fuels. It wasn't called that then. And I tell people I thought fuels was interesting until that time, and I realised actually it was quite boring. It has been really interesting since that time. And I can remember a meeting in 2002 across in the States where the engine manufacturers and the airframers actually got together because there was this big challenge to say that automotive, you've got biodiesel, you've got ethanol in the gasoline or petrol. What's aviation doing? It's doing nothing. So had to explain, and we're on a journey now to get that to fruition. We had to explain why jet fuel is how it is, the fact that it's a critical component of aerospace and aircraft and engines. And we said, if you want to get sustainable materials into jet fuel, this is how you have to do it. And I'm going to talk about that. So I'm going to talk about what people mean by SAF. I'm going to talk about some of the challenges and issues and some of the important points going forward. So it's a different picture. Oh, no, it's not, sorry. So what's the definition? Okay, well, the simple definition of sustainable aviation fuel, or sometimes called renewable aviation fuel, is jet fuel, as opposed to taking carbon out of the ground, that's been there sort of a couple of million years, is taking it from biomaterial, plants, even animal fats, used cooking oils, all those sorts of things, and actually turning it into jet fuel. So you're taking carbon out of the atmosphere while those plants are growing, turning it into jet fuel, and yes, you're putting it back, but in theory, you can get a circular carbon economy. I say in theory. There's obviously, when we talk about sustainability, there are some key issues there. You know, we've all seen the bad news about chopping down rainforests and planting palm oil and stuff like that, so there's some big mistakes done there. There's also the use of water, use of agricultural land, and there's all the social aspects, so we've really got to look at that carefully. Okay, so for a sustainable aviation fuel to be viable, it needs to meet three key attributes. The first one is it's got to be technically suitable. And I must admit a bias because I come from Rolls-Royce, so when I was in Rolls-Royce and as I continue as an independent consultant, I sort of sit with my feet in two camps. One camp's in the engine and airframe technology area, understanding how the fuel impacts on that, and the other foot is in the industry that produces conventional and now sustainable aviation fuel. So technical suitability, and people have talked about energy density. Yes, that's important. People have actually talked about heat management on these systems. Well, the fuel is a coolant for the airframe and the engine, and it gets hot, so it's got to operate and withstand that. It's also got to operate at very low temperature in the wings, so it's quite a challenging thing. So just burning it is important as well, but there's other things that it does as it goes through. So meeting all those technical requirements. I've talked about sustainability. If it's going to be sold as SAF, then it's got to be truly sustainable. And the last one, and one of the challenges, is it's got to be commercially viable in that you've got to be able to make sufficient quantity of the material to make a difference, and it's got to be commercially viable in terms of its price. So the target is, of course, I've talked about if you make it in a carbon neutral cycle, then the CO2, the net CO2 of conventional fuel, all the carbon that comes out of the ground goes into the atmosphere. If you're absorbing it, then you reduce that. It can have some other benefits because most of these fuels are highly processed and then blended with conventional jet fuel. So they have got some benefits in terms of tend to be very clean burning. And terminology here, they're actually synthetic because they are hydrocarbons. They're nothing like the original materials. And I will talk about the original materials and the processes in a moment. And drop-in is quite important terminology just to define that. It's a term that the industry has adopted. Bear in mind, an aircraft and an engine, and most of you are probably aware of this, is certified to operate within a operational limitations. It's got this whole list of rules that the aircraft has to comply with to be airworthy and safety and carry passengers. And one of those is the fuel. Okay, so so if we change the fuel, drop-in fuels wouldn't work because we'd have to recertify all the aircraft. Two routes mainly. You get the biomass into fuel. You've also got the power to liquid or e-fuels. This is where you use sustainable energy to get carbon dioxide and water, turn them into jet fuel. There's a complicated chart here. I'll just highlight, these are some of the routes that you can use. I think this will be in the pack. I'll go through them very briefly. The original one was actually Fischer-Tropsch, and it was actually coal to liquid, but it set the ground to be able to do other things. And of course, the power to liquid is actually Fischer-Tropsch. So you produce carbon monoxide and hydrogen from water and carbon dioxide, and then you turn it into jet fuel. HEFA is a material that you just get plant oils and greases, anything like that that's, like palm oil. I know palm oil's got a bad name, rapeseed oil and so on. It's a much less process intensive, and that's the one that's used commonly. And then these are some of the other things, anything that's fermentable to turn into sugar or alcohol and then into jet fuel. So there's quite some different ways of getting there. Some of the key challenges is the cost of approval. We have to prove that these products are technically equivalent to conventional fuels, because otherwise you hazard the certification and airworthiness. And it's quite a rigorous process there with the gatekeepers of the OEMs, although the rest of the industry has to approve it. We're trying to make that process better and easier. If you went through the whole process, it'd probably take you 2 to 3 years and $2 to $3 million. The fast track process with lessons learned is trying to reduce that, and we're also doing research to try and be smarter. The big challenges at the moment is the cost of approval and the diversity of feedstocks and processes, and it's loading the industry up, the OEMs particularly, with a lot of work. The cost of the final product, we've heard some numbers. Some of these are 2 or 3 times the price of conventional fuel at the moment. And part of that is the raw material, and part of it is the cost of processing it to get it to an aerospace standard. And then the sustainability measurement is several different methods of measuring the sustainability. So I've had the sign waved at me. So we require a drop-in, and there isn't anything viable as an alternative, certainly for long to a medium haul. We've heard that. So how much can SAF actually contribute? The take-up is low at the moment, but it's early days. We're on the journey to get there. Yes, if we're going to carry on with aircraft, and bearing in mind, we're talking about aircraft that have been in service 30 years are still out there. It has to be compatible with them. An aircraft being launched today or being produced and sold to the market today will be out there for 30 years. So, we've got that legacy to look after. We are working at the challenges as an industry, but, there's probably more to come, and that's part of the panel debate. I'll leave you with a gratuitous figure at the end, a bombshell. I did a quick search on Google, and although different people say different things, 100 billion gallons of jet fuel per year is projected for 2019. So it's a big number. Thank you.
Thank you. We now move to the side of the panel session. I will just put up the Slido again. We've had some questions come in. The number again is 4167, and we're on Vox for Environment. Okay, so we've had some questions come in. I'll just pick and choose some of them by order of interest from the audience. We have a first question, which is, it's a general question for the three of you, and it's if we had to speed up our reaction to the environmental agenda, what would you do first and most? Roger, would you care to start?
Okay, yeah. I'd actually pursue the fuels story. I don't want to steal Chris's story, but it's clearly the one where there is real potential to do something on the basis that if it's liquid fuel for long haul ad infinitum, then there has to be a route to either SIN or e-fuels or whatever that will actually enable that to be delivered if we're not going to impact growth as previously stated. So I see that as being an essential part, given that it represents a very sizable slice of the overall CO2 impact. However, I also think that we need to be very pointed about trying to narrow some of the option field on technologies so that we can actually then invest over more controllable timescales to deliver new technologies that are actually step change.
You talked about a bifurcation between the long haul and the new markets. I'm guessing your view would be different for these new markets in terms of what we should be looking at speeding up.
Certainly, if you're looking at short haul, I would entirely advocate that we do pursue the electric and hybridization route, but that still seems to have very significant hurdles attached to it. So I don't think we can take the foot off the gas, bad pun, in relation to actually supporting the longer term, bigger picture of the gas turbine and liquid fueled futures.
Thank you, Roger. And Martin, since Roger has addressed the sustainable aviation fuels, would you mind explaining or expanding on some of the technology solutions that have the more potential?
Yeah, I was going to add a piece to that, if I may, Christina. You saw that one of the key challenges is actually not the speed of technology development, but it's actually the speed of introduction into the marketplace, because they are disassociated, if you will. And that's partially because of the expectations from the operators on the level of improvement in product they will get for the cost they're paying for that product. So if you have a very, very low fuel cost environment, the incentive to change that product is low. If you have a high cost environment, the incentive to change the product is correspondingly high. So sadly, if you really wish to push the technologies in as fast as you possibly can, you have to end up in a very, very high fuel cost environment. And I think that will help stimulate the pace at which the technologies gets in. I think the development of technology is actually in a reasonable pace, but it's when it will get into the market right now in the current environment, to me, that becomes the challenge. So I think with the near-term technologies, we're doing all the right things. Longer-term technologies, as I hinted in my presentation, maybe there's some areas we need to do some more homework on and maybe look at some of those technologies again because the potential benefits are high. But in the near term, I think I would look at an environment where you end up with speeding up the clock in terms of the replacement cycle because the airlines are incentivized to do so.
Thank you, Martin. And since I'm guessing that, Chris, you will vouch for sustainable aviation fuel?
Yeah, I mean, because we stuck with them. I recognise being part of this industry and looking outwards from sort of an engine and less of an airframe but more an engine point of view, the industry has been very challenging in terms of getting these fuels approved. And aren't you glad that we are, because fuel is one of the few common mode failures. If you get the fuel wrong, you haven't got a backup. So some of the strands of my part of the industry, the first is, as I say, we're trying to make the process easier and quicker and cheaper so that there's less of a barrier. We're secondly looking to be more intelligent in terms of how we assess and evaluate these fuels to predict how they behave. That also means that we can start opening up the scope in terms of what materials are acceptable. If I was fair to the industry, the refining and production industry, we're actually really come down hard on these people because when they come along with these new products, because if they say I'm going to get sugar and brew it up and then turn it into jet fuel, we go, oh no, it's new, so we're cautious. And I think, I don't want to use the term relax, I think we need to be more rational. And the last one is, a lot of people want to get into aviation fuel supply, and it's a very difficult industry, and one of the barriers is understanding what the rules are and what the procedures are. And actually, you know, in 2002 we actually started writing the rules, so the rules are quite new. And understanding engagement with stakeholders is important, and we're trying to do some initiatives to try and help the people through that difficult process at the start. So that's getting it approved. In terms of the commercialisation and what have you, it's a really difficult one because, you know, the problem we've got is actually jet fuel is so cheap. And these are more expensive, but you know, we're doing what we can to help. Now if there was, I mean, courses coming along and things like that, so that could help offset the difference. It's interesting that the only jet fuels, the sustainable aviation fuels that are being used on a regular basis are through partnerships. Almost all of them, jet fuel's a commodity that's traded, but there are partnerships being set up between the airlines, the suppliers and the producers. So more of that and help on that could help as well to get it in the market.
And may I ask, just out of curiosity, biomass to liquid or power to liquid?
That's a good question. At the moment, I think biomass to liquid has a place. People are also looking at municipal waste and plastics and things like that. So rather than, yes, it's still carbon out of the ground, but we're reusing it again and also taking carbon out of stacks. Power to liquid is a new technology. It's coming online. I think, like the fact that we're looking at operations, aircraft and fuels, I don't think there's any one single solution to making jet fuel. We've got to look at all of them and cope with them and make sure we facilitate their approval and into the marketplace. I wouldn't necessarily put my eggs in one particular basket.
Mm-hmm. We have another question on the aviation fuels, and since we are now with you, I'll just go ahead and ask, do you think aviation alone has the demand requirement for sustainable fuels to reach the economies of scale required? Yes,
that's actually an excellent question. I did see it on my phone earlier because I thought, you know, pre-warned is pre-armed. It's actually, it's actually the other way around. The problem aviation has got, to be absolutely brutally honest, is it is very difficult to get these bio materials, and even Fischer-Tropsch produces a wax which then has to be processed afterwards to get it to a point where you could put it into even dream of put it into an aircraft. If you wanted to turn it into, say, petrol or diesel or heating oil, that's actually much easier. So the question is actually the other way around, is that other easier to enter markets are actually competing with us. So it's not a case of do we get the critical mass by aviation? It's the other way around. Can we get to a point where aviation is attractive to these people? And I'm sorry, it sort of doesn't answer the question, but that's the reality. But of course, if you're making a Fischer-Tropsch wax, then that does produce other materials as well. Not many people actually make dust jet fuel. So the challenge is it's going into other markets rather than aviation. So it's not a case of critical mass, it's a case of competition.
Thank you, Chris. We have another question. With current and growing pressure on addressing climate change, are the growth rates of aviation realistic in your view?
I think the growth rates are still realistic, and I don't think one should shy away from them. As you said yourself, the problem is carbon, CO2, rather than growth. Yes, there may be some dent as a result of fleet scam and other things of that nature, or indeed from increasing concerns that people actually experience firsthand about environmental impacts. But the history, as Robert said earlier, is that it is solid compound growth of 1 point whatever times GDP, and that doesn't look as though it's going to change. So I don't see that we need to really spend too much time arguing about the growth number. I think it's more about what the solution space is, and that, I think, is the area where we should be putting more effort in, especially things like trying to map out very clearly what the pathways are towards 2050, towards net zero. And I think that net zero is an achievable goal. It may require removals and BECS and all sorts of other technologies that are actually going to complement technology improvements and alternative fuels. But that means that I don't think one really needs to be overly spending time about growth, because I think that's almost beyond the control of people in this room.
Thank you. Martin?
I think in answer to that, I would go back to the presentation I saw from James this morning, which really took my eye. There are 3 scenarios there. In one of the scenarios, you could imagine that we will carry on with unfettered growth, if you like, market demand driving that, and all the statistics look very positive in terms of GDP, in terms of those who haven't flown, in terms of salary growth in less developed areas, and the willingness and preparedness to fly. So from that perspective, I think, yeah, it can continue. The other 2 scenarios, if either of those 2 come to fruition, I think is far less clear. Government intervention is a possibility, particularly if we as an industry don't get our act together and don't make it clear that we are going to achieve those targets that we've set ourselves. So I'm less sanguine than Roger. The thing that I really take away, though, and this is not my comment, this was a comment from the previous session for those who weren't here, and the question was this, that if the rate of growth falls, how does the industry pay for the technology development to put the improvement in the first place? Because the investment isn't there. And I thought that was a fabulous observation, and it paints us right into what I would call coffin corner, which for those who fly know what I mean by that. We're right in the corner between having to do something about it but not being able to afford to do it.
Thank you, Martin.
Well, I can only echo the other 2 speakers, really, from my point of view. I mean, I think the message that I've took away from today, but I was aware anyway that, the aerospace industry is doing everything they can, and mobility, social mobility, and the wealth it generates, and actually flying, certainly intercontinental, is probably, the most efficient and fast and convenient way of flying. So I think all we can do is make it as environmental as we can, and then let people decide.
Mm-hmm. We have a question on perhaps some of the technology assessment within the ATA and L&D paper. It's regarding Airbus announcing its fellow flight demonstrator, which is formation flight. And what are your thoughts on, because it wasn't included in the assessment?
I'll explain why.
Okay. When we looked at the analysis that was available on the public domain on formation flight, it was kind of very interesting. There was some potential there. The potential wasn't actually that great in the end in terms of its overall improvement in fuel burn. So that put us on the back foot for a start. The thing that really struck us though more than anything else, and I guess that when we wrote this we were perhaps less well versed in modern swarm theory and those kind of things, was that it sensed to us that there was a huge, great big ATM challenge to actually achieve that. If you think about what ATM does today, it spends all its time keeping them apart. It doesn't bring them together. And so it's a fundamental sea change in how that would work on large commercial transports in bringing them together for a large proportion of the flight. Bear in mind, of course, that the takeoff, the climb, the descent is not going to be done that way. It's cruise. It'll only be a proportion of the cruise as well. So when you look at those all together, the numbers in terms of CO2 improvement were actually relatively low. So in combination with that and the ATM challenges that we saw at the time with the levels of technology we thought were available at the time, we thought that it was probably interesting, but on the very challenging par rather than the one that looks as if it would be relatively straightforward to go and do.
We have time for one last question, and I'm just going to scroll down to one that is applicable to get your views from the three different perspectives. Is UK net zero carbon target, in your view, appropriate for aviation?
Okay. Yes. Simple answer, absolutely. I think it is. I don't think this sector can move away from that as a central goal in the way that many other sectors are expected to do so. Okay, it's going to be in a different route. It will require things that are nothing to do with technology, but as a sector, it's absolutely essential. So a strong vote from me, yes.
I would agree with a caveat, and the caveat is this. I think that in terms of achieving aerospace and carbon neutral, I think it's not a UK role to do that, it's a worldwide role to do that. And so I think setting it up independently opens us up then to other challenges where other organisations or other countries choose not to do it. It then has this whole competitive issue where we're doing things that other countries are not doing, and so the question then becomes whether governments are going to be prepared to do that.
Yeah, and I'd support that sort of global view. People often say, well, you know, like the automotive industry had different fuel types for different countries and different regions, and you couldn't necessarily operate a European car straight off in the US some years ago. I was talking to somebody at lunch about that, and people didn't realise that. But you can't have that segmentation in aviation. It has to be global. So whilst, yes, those are the right targets to go for, it must be recognised that we're in a global market. But as we heard yesterday, I think it's important that the UK should be a leader in terms of bringing the global industry towards those targets.
Right. Thank you very much. I just have one more slide to summarise a few of the points we've touched on today. I think we can all agree that environment and aviation is global in nature. So then issues and measures should be, whenever possible, applied at a global level. We've talked about much of the need for acceleration in the pace for development, for integration of solutions to tackle the environmental challenge. We've seen from Roger and from others that this is very much a multidisciplinary optimization problem. We need to look at the full life cycle. We need to look not only at carbon, but other sources of environmental impact as well. Policy measures will be required. Technology, as we've seen today, is not going to get us there all the way in reaching our targets, and cross-sectoral collaboration will be crucial. We know very little about carbon capture as an aviation industry. We know some about sustainable aviation fuels, but it is not in the core of our technology development and aims. So with that, I leave you, and thank you very much for your contributions today.